He had picked the right hedge, 4 feet of packed Norman earth, topped with roots so dense you couldn't cut through them with a saw. He'd chosen his angle the night before. He had the right weapon, the right range, the right moment. He was wrong about all of it. He could hear them coming. Steel on gravel, the diesel rumble you felt in your chest before you heard it in your ears. The column rounded the bend. He sighted. He fired. The Sherman was already turning. Not braking, not stopping. Turning. Its turret swinging toward him faster than anything that size had any right to move. He had one shot. He took it. And then, in 15 seconds, everything about the way this war was being fought changed. The answer had already been found. On the other side of the world. By a man nobody remembers. This is why. The M4 Sherman. That's what he was trying to kill. 49,000 of them were built before the war ended. More than any other tank fielded by any nation in the conflict. One completed tank every 14 minutes at peak production. The paint was barely dry when they loaded them onto the rail cars. The Germans had a name for it. 2, actually. The British called it the Tommy Cooker. American crews, gallows humor being the universal language of men who sleep inside fuel tanks, knew it as the Ronson, after the cigarette lighter company's famous slogan, "Lights, first time, every time." The reputation was earned. Shermans burned. They burned often and they burned fast, and the men inside them understood the math. A penetrating hit in the wrong compartment, and the ammunition cooked off. Survivors described hearing the rounds going off inside the hull, like a string of firecrackers, if they were far enough away to hear anything at all. So here is the question this story is really about. That tank, the one with the nickname, the reputation, the body count, is the same vehicle that Germany's professional anti-tank infantry described in their after-action reports as nearly impossible to ambush, not difficult to engage, not well protected, impossible to ambush. Those words appear in German field reports from Normandy, from Lorraine, from the Ardennes, written by men whose job, whose training, whose entire tactical purpose was the destruction of enemy armor. And they couldn't reliably do it to these ones. How does that happen? On paper, it shouldn't. The Sherman had thinner armor than a Tiger or a Panther. Not marginally thinner, significantly thinner. Its main gun was outranged by the German 88mm on any open ground. Tank against tank, in a straight duel, the math favored the Germans. Every specification comparison puts the Sherman in second place. But 1944 wasn't a tank duel. It was a war. And wars are won by systems, not individual machines. For 60 years, the story got told the wrong way. We counted the burned hulls and drew the obvious conclusion. We built comparison charts, armor thickness, gun caliber, kill ratios in one-on-one engagements, and declared the American tank a disaster. What those charts couldn't capture was everything built around it. The 3 things that transformed a vehicle, the manual said, should lose into one. The enemy said they couldn't stop. The first was communication, or rather, fixing a communication problem so obvious it's embarrassing it existed at all. The second was mechanical, a turret that moved like nothing the Germans had seen or planned for, so fast that 30 tons of steel seemed to violate basic physics. The third is the one nobody talks about, a piece of improvised equipment the Army didn't design, didn't order, and didn't fully understand, until German infantry stopped winning ambushes and started dying in them. General Richard Schimpf commanded the 3rd Fallschirmjäger Division, some of the best infantry Germany put in the field. His men understood the Sherman's weakness in those first weeks of June. His Panzerfaust teams had success. With the formula worked. Find the road, pick the hedge, let the blind machine come to you, take your shot, fall back. For a few weeks that formula held. Then it stopped. Not gradually, fast. Something had changed inside those tanks. Something the Germans couldn't see from their side of the hedgerow. Something that had broken the geometry of every ambush they'd spent weeks perfecting. For 60 years, one side of the story was told. This is the other side. Part of the answer came from a jungle that nobody in Berlin, Paris, or Washington was paying any attention to. A man nobody remembers walked out of it with the piece of the puzzle that cracked the bocage open. Everyone knows the Sherman burned. What nobody told you is what happened to the men who lit the match. To understand the problem, you first have to understand the ground. The Normandy in the summer of 1944 was not the open rolling countryside of the liberation photographs. Most of those photos were taken later, further east, After the army broke out into open country, what the first American soldiers actually moved through in June, and July was something else entirely. A landscape that looked, to a tank crew, less like France and more like a maze built specifically for the purpose of killing them. The bocage. Thousands of small fields, each one enclosed by earthen banks that had been building for centuries, packed down through generations of farming and weather, until they were hard as masonry, not hedges in any decorative sense. 4 feet of compacted earth at the base, topped with 15 feet of root systems, so dense and intertwined, you couldn't cut through them with a chainsaw. The lanes between the fields were sunken below the level of the banks, barely wide enough for a single vehicle, sometimes not even that. The sky above was a strip. The walls on either side were alive and ancient and utterly impenetrable. A tank could not go over those banks. A Sherman attempting to climb one would tip its nose up and expose its belly, the thinnest, most vulnerable section of its armor, to whatever was waiting on the other side. So they stayed on the roads, and the roads were corridors, and corridors have 2 ends, and anyone with a weapon and the patience to wait knew exactly where the tank was going to be, and exactly when it would arrive. This was the first problem, the terrain, and there was no tactical solution the army had written a manual for, because the maps hadn't prepared anyone for what the bocage felt like from inside a moving vehicle at 5 miles an hour. Inside a buttoned-up Sherman, the world contracted to what the periscopes allowed, a 10-degree cone of vision, moving down a sunken Norman lane with dirt walls on either side. That cone shows you about 6 feet of hedgerow to the left and 6 feet to the right. You cannot see the man with the Panzerfaust unless you are almost on top of him. You cannot see him reload. You cannot see him shift position. You are inside a steel box that is loud, dark, and vibrating, and the man who wants to kill you is 3 meters away in the root system, and you would never know it until the shaped charge came through the hull. This was the second problem, vision. And then there was the third, the one nobody should have allowed to exist. The tank radio and the infantry radio operated on incompatible frequencies. That is not a metaphor. That is a literal description of what was happening on those Norman roads in the summer of 1944. The infantryman, walking 6 feet behind a Sherman, the man who could see everything the tank commander couldn't, had no way to speak to the man inside. The radios simply did not talk to each other. A soldier who spotted a Panzerfaust team in the hedgerow had exactly one option: run to the tank, bang on the hull with his fist, and hope that between the engine noise and the closed hatches, someone heard him and understood. In an ambush, you don't have time to run and bang on a hull. In an ambush, you have seconds, sometimes fewer. The German anti-tank teams in Normandy understood this before the end of the first week. General Schimpf's Fallschirmjäger went into Normandy carrying a real institutional fear of tanks. The Wehrmacht called it Panzerschreck, tank terror, and they meant it literally. Men who had fought on the Eastern Front, who had watched T-34s grind through positions that should have held, sometimes froze at the sound of engines. German medical units documented it. German commanders knew it. They dealt with it as best they could. Then they started fighting in the bocage, and the fear went away, because the tank in the bocage wasn't the T-34 rolling across open steppe. It was a 60,000-pound machine inching down a sunken lane, completely predictable, but separated from the infantry that should have been protecting it by 2 incompatible radio frequencies. The Fallschirmjäger learned this within days. Their Panzerfaust teams identified the choke points, pre-positioned on the banks, and waited. The formula was almost mechanical. Find the road, pick the bank, engage the second vehicle as it stops behind the first, fall back through the hedge before the Americans can respond. It worked. Through June and into July of 1944, it worked. The casualty reports from that period make uncomfortable reading if you are an American armor officer. Tanks destroyed by infantry anti-tank weapons in terrain, where, by doctrine, they should have had infantry protection. The infantry was there, walking right alongside the tanks, sometimes 3 meters away. None, they just couldn't talk to the man inside. Somewhere in the United States Army, someone already knew this. Someone had already found the fix. Not in France, not in any theater the European planners were watching. The fix existed in a Pacific after-action report, in a stack of paperwork working its way through channels that moved considerably slower than the war did. The question was, whether it would reach Normandy before the casualty lists got any longer. By the summer of 1944, German infantry had a terrain, a weapon, and a doctrine that worked perfectly together. The system was locked, the geometry was solved, and then someone broke the geometry. Nobody in Paris expected the solution to come from a jungle island in the South Pacific. Bougainville, November 1943. The island sits in the Solomon chain, roughly halfway between Australia and Japan, and in the fall of 1943, it was one of the uglier places on Earth to conduct a ground war. 1,500 square miles of volcanic rock, triple canopy jungle, malaria, and Japanese fortifications dug into terrain that had never been intended for human occupation. The 37th Infantry Division landed there in November, with the 754th Tank Battalion in support. The mission was to push through the jungle toward the airfields the Japanese had built on the island's northern coast. The 754th Shermans hit the same problem within their first week that European planners were still writing memos about. Jungle terrain and hedgerow terrain have almost nothing in common on a map. On the ground, inside a tank, but they feel nearly identical. Zero visibility, unpredictable enemy contact. Infantry that can see threats, the tank cannot. A tank commander, buttoned up inside his hull, navigating by periscope, cut off from the soldiers walking directly alongside him. Someone, in the 754th Tank Battalion, decided this was unacceptable. The historical record doesn't give us a single name. This is the frustrating truth about most tactical innovations. They emerge from a collective frustration, tried by one crew, adopted by a platoon, until someone in a command position notices it's working and writes it up. What we know is that the fix came from the unit level. It did not come from Washington. It did not come from a weapons development program or a technology research committee. It came from an ammunition can. Someone found a standard field telephone, the kind of battered piece of equipment that every infantry unit in the Pacific had piled in their supply dumps. Someone welded a metal box to the rear hull plate of a Sherman outside the tank, accessible to infantry. They ran a telephone wire through the hull. Inside the tank, the commander had a handset. Outside, the infantryman walking behind the tank had a handset. When the man outside saw something, a Japanese position, a likely ambush point, anything the tank crew couldn't see, he picked up the phone and said so. The Sherman commander, instead of being a blind man driving a 30-ton machine through a jungle, was suddenly connected. He had eyes outside his steel box. He had someone who could see over the next ridge, around the next bend, into the roots of the next tree line. And those eyes had a telephone. It was not sophisticated. It was not elegant. It was an ammunition can and a telephone wire, equipment every infantry company already had in its kit, welded to the back of a tank by men who were tired of watching their armor blunder into positions that could have been avoided. It worked so well that the U.S. Army standardized it. Bougainville, November 1943. Normandy, June 1944. 6 months from a field improvisation by an infantry battalion in the South Pacific to an official modification being installed on American tanks before the largest amphibious invasion in history. 6 months. The German Army's procurement process, built on hierarchy and formal written requirements, could not have moved from concept to fielded equipment in 6 months if the concept had come down from Hitler himself. This was the man nobody remembers. Not one man, an institution. A culture that allowed a sergeant's improvisation to become army policy faster than the Heer could revise a training manual. The German military system was technically superior at the level of the individual weapon. What it couldn't do was take what worked in the field and spread it before the war moved on. A German soldier who found a better way had to push the idea up through a command structure under pressure to win battles, not update doctrine. The Americans routed it sideways, to the next unit, the next commander with the same problem, and let it spread before anyone in Washington even knew it existed. Now, back in Normandy, that telephone was about to meet the bocage, but the phone was only part of what changed. The second piece is the stranger story, and the more purely American one. His name was Sergeant Curtis Cullen. He served with the 2nd Armored Division, and in July 1944 he had a problem, a pile of materials, and the kind of practical mechanical intelligence that the United States Army had an almost inexhaustible supply of in that war, even if it didn't always know how to deploy it. The materials were simple: German steel. Specifically, the steel obstacles the Germans had welded into the beaches at Normandy to stop landing craft. The hedgehogs and angle iron that were now sitting inert on the sand. Cullen looked at those obstacles and saw something the Army's engineers hadn't recognized yet. He saw cutting blades. The problem was the hedgerow banks, 4 feet of compacted earth and 15 feet of roots. Tanks couldn't go over them without exposing their belly armor. Every American armored officer in Normandy understood this. The standard response was to find a gap, a gate, a road junction, an existing break in the bank, and route the tank through it, which meant the Germans knew exactly where the tanks were going to emerge. Every gap in every hedgerow along every road was a potential kill zone, pre-registered, pre-targeted, already burned into the Panzerfaust team's mental map. Cullen welded his salvaged German steel into modified blades and mounted them on the lower front hull of a Sherman. When the tank drove at a hedgerow bank at speed, the blades bit into the earth at the base, not over the top, where the belly armor would be exposed, but through the side of the bank, from a standing start. The tank didn't climb. It pushed. It bored through. The Sherman came out the other side in a shower of dirt and roots and startled Norman countryside, where the Germans expected a tank to appear, on the road, at the gap, at the choke point they'd been watching for hours. There was nothing. And then, seconds later, a Sherman materialized through what had been a solid wall of earth. Eisenhower saw a demonstration and ordered it into production immediately. By the end of July 1944, the majority of the American tank fleet in Normandy had been modified with Cullen's device. They called it the Rhino. The steel for most of them came from the beach obstacles the Germans had built to stop the invasion they'd already failed to stop. The tactical effect on German anti-armor planning was immediate and decisive. Their entire doctrine rested on a single assumption: the tank will use the road, and the road brings it to us. Remove that assumption, and the Panzerfaust teams were positioning themselves in the wrong places, watching the wrong gaps, waiting for a tank that never came, because it had gone through the wall instead. They didn't know the geometry had changed. The Sherman commander was no longer locked inside his turret, blind, guessing. He was borrowing someone else's eyes, and the tank itself could go anywhere. The Germans couldn't see who those eyes belonged to. They had no idea how to counter it, and by the time they understood what had changed, they were out of time. The telephone was in the tank. The Rhino blades were on the hull. Every piece of the machine was moving into position. What happened when a German ambush team met a Sherman that could see them, drive through walls, and turn its gun in 15 seconds? That's where the numbers get brutal. So here is how it actually worked. A Sherman was moving down a Norman lane. The tank commander was not buttoned up. The hatch was open, his head above the turret ring, trading the protection of steel for something worth more: peripheral vision. That's the first thing the history books get wrong. The late war Sherman commander was not sealed inside his vehicle like a man in a submarine. He was the tank's eyes. He took the risk because staying buttoned up, seeing nothing, that got people killed. Behind the tank, an infantryman held a handset. The wire ran from his hand to the metal box welded on the Sherman's rear plate, through the hull, to the commander's position. The man walking behind could see the lane walls, the route lines, the shadows that didn't move the right way. When something was wrong, he didn't shout, he didn't wave, he didn't run forward and bang on steel. He picked up the phone. Panzerfaust team, 11 o'clock, 25 meters, in the bank. The commander didn't relay that through the radio net. He didn't call up the company commander for authorization. The entire chain, threat spotted, threat reported, weapon aimed, ran through one handset wire and one hydraulic pump, and it ran in seconds, not minutes. That is the thing the comparison charts miss entirely. Not armor, not gun caliber, turret speed. The speed at which 30 tons of steel could pivot its main weapon onto a new target. That variable rewrote every tactical equation the Germans had been using since June. The Sherman's turret ran on a hydraulic traverse system, oil gear, or Westinghouse drives, depending on the production batch. At full power, the turret completed a full 360-degree rotation in 15 seconds. 15. The entire circumference of a tank's field of fire, covered in less time than it takes to lace a boot. It was not a dramatic machine. It did not look fast from the outside, but that turret moved. Compare it to a Tiger one. The Tiger's turret was driven electrically. and its traverse speed was directly tied to the engine's RPM. At standard idle, the speed a tank uses when it's holding position in an ambush, conserving fuel, on trying not to announce itself. The Tiger's turret required up to 60 seconds to complete a full rotation. 60. 1 full minute to swing the gun from one side of the tank to the other. To achieve its fastest traverse of approximately 19 seconds, the driver had to run the engine at 2,000 to 3,000 RPM. That is near redline. It was loud. It was mechanically punishing. And in the bocage, where sound carried through the earth walls and infantry knew exactly what a straining engine meant, it was a warning. The Panther was worse. The Panther OSFD's turret was mechanically fixed at approximately 60 seconds, regardless of engine speed. All the throttle in the world bought nothing. Brigadier General Albin Erzik commanded the 8th Tank Battalion, the 4th Armored Division, one of the most effective armored units the U.S. Army fielded in the European theater. He wrote about the geometry of the Tiger encounter with the measured precision of a man who had thought carefully about why he was still breathing. The Tiger's strength, Erzik understood, was the first shot. The 88mm gun was accurate at ranges where the Sherman's 75mm was marginal. If the Tiger acquired a target and fired accurately before the Sherman could respond, the engagement was over. That was the German tactical philosophy in every theater. Superior weapon, decisive first shot, close the fight before the enemy could react. It was built on a reasonable assumption. It did not account for what happened after the Tiger missed. A Tiger that missed its first shot at idle engine speed, that in an ambush position, had approximately 60 seconds to reacquire and fire again. In those 60 seconds, Erzik's crews were not stationary. 5 Shermans in a platoon, each with a 15-second turret traverse, were already moving and turning, not retreating, moving to the flanks, moving toward the side armor that the Tiger's designers had made 60 to 80 millimeters thick at the front and left at roughly 45 to 80 millimeters on the sides. Armor that a 75mm round at close range could defeat. 5 Sherman turrets, 15 seconds each. In the window, the Tiger needed to reload and re-aim. An American platoon could put 15 to 20 rounds of 75mm ammunition in the air, high explosive to force the German crew to button the hatches and lose their visibility. The armor-piercing aimed at the flanks. The tank commander on the radio was not reacting in panic. He was executing arithmetic. The Americans had built for this exact moment. The Germans hadn't fixed the weakness that made it possible. The telephone told the Sherman where to look. The hydraulic turret answered before the threat could fire twice. The infantry, in communication with the armor, cut off the retreat. The fundamental ambush plan, fire, fall back, reset, collapsed the moment the first shot missed, because the Sherman was already looking at the firer before he could decide which direction to move. Erzik was not describing luck. He was describing a system that had been built to win the 30 seconds after someone pulled a trigger. The third piece was a gyroscope. The Westinghouse gyroscopic stabilizer was fitted to most Sherman production variants from relatively early in the war, and it did something the German crews who survived their first encounter called impossible. It allowed the Sherman's main gun to hold its aim while the tank was moving. Every other major tank of World War II operated on the same assumption. To shoot accurately, you stop. You find your position, you halt, you stabilize, you fire. The Tiger stopped. The Panther stopped. The T-34 stopped. Stopping was not a choice. It was mechanical necessity. A tank moving across uneven ground is a platform in continuous vibration, and a gun mounted to that platform follows every bounce and pitch without compensation. The Westinghouse stabilizer used a spinning gyroscope to hold the gun's elevation independent of the hull's motion. The result, the Sherman's gun elevation error while moving, was less than 1/20th of a degree. At ranges between 300 and 1,200 yards, typical bocage engagement distances, this translated to a 70% probability of a first-round hit while the tank was traveling at 15 miles per hour. 70% while moving. The Panzerfaust team in the bank had built their plan around a tank that would slow as it entered the kill zone, a target that would stop and hold still. What arrived was a tank still accelerating, its gun already tracking the route line, suppressing the hedgerow with main armament before the man behind the Panzerfaust had finished his trigger pull. The tank never paused. The doctrine required it to pause. It never did. And before the column even entered a corridor where the phone had identified a suspected position, there was one more step in the sequence. The infantryman on the handset had spotted something, not confirmed. A gap in the route pattern where there shouldn't be one. A depression in the earth that looked disturbed, a shape. He reported it. The tank commander didn't wait for the Panzerfaust to confirm itself by firing. He called for white phosphorus, Willie Pete, a wartime nickname for a weapon with a specific and terrible personality. The round hit the bank and produced white, not orange, not the color of conventional fire. White, intensely hot, chemically sustained, burning at over 5,000 degrees Fahrenheit, attaching to whatever it touched and impossible to extinguish by smothering. And the smoke it generated in the first seconds was thick, directional, and blinding. The effect inside a hedgerow position was immediate disorientation, then heat, then the choice. A Panzerfaust team that took a white phosphorus round in its position had three options: hold the position and burn, break cover and run, exposing themselves to the Hull machine gun, to the open hatch commander, already scanning for movement, to the infantry closing on the flanks, or drop the weapon and pray the smoke covered the retreat. In none of those three options did they fire a second rocket. The telephone, the turret, the gyroscope, the burning fog. Each piece came into the Sherman a different way, adopted for different reasons, solving different problems. Together, by the fall of 1944, they had produced a number that German after-action analysis struggled to rationalize. A Panzerfaust team, operating in the bocage, under professional doctrine, in terrain specifically suited to their weapon, against an enemy who should have been at a disadvantage, had roughly a 10% success rate against American armor. 1 in 10. The terrain was theirs. The range was inside the weapon's effective envelope. The ambush position had been carefully chosen. Success rate, 1 in 10. And if the team missed, or was spotted before firing, the probability of death or capture for the firers rose to approximately 73%. Not from a counterattack organized over hours. From the 15 seconds following the phone call to the Sherman commander, a weapon that works 1 time in 10 in its optimal environment, while guaranteeing a 73% casualty rate for the men who carry it out. At what point does that stop being a tactic? The German command eventually arrived at the answer arithmetic always produces. By late 1944, official Wehrmacht doctrine acknowledged that direct infantry anti-tank action against American armored columns in Normandy-style terrain had become, in their own language, tactically unproductive. Tactically unproductive. The German army's bureaucratic phrase for, "we couldn't do it anymore." The man in the hedge, from the beginning of this story, the one who picked the right bank, the right angle, the right moment. He followed the doctrine his commanders had written. He did everything the training said to do. The Sherman was already turning, and the math was settled by the end of 1944. The Germans understood every number in it. Understanding a problem and solving it are two different things. And by the time they understood this one, they were already out of time. The proof came in August 1944. 2 battles, fought within weeks of each other, that demonstrated not the system at its best on paper, but the system under the precise conditions that should have destroyed it. The first was Mortain. On the night of August 6th, Hitler ordered a counteroffensive that was, on paper, a reasonable operational gamble. 8 panzer divisions, roughly 1,000 armored vehicles, would drive west through a corridor near the town of Mortain, cut the Allied supply lines, and sever the American breakout force from its fuel and ammunition. The commanding generals in the field privately concluded it was not a sound plan. They executed it anyway. The assault began in fog, dense, ground-level fog that rolled off the Norman hills and reduced visibility to 20 or 30 yards. Fog had always worked for German armor. It neutralized Allied air power. It confused defensive positions. It gave the attacker the initiative, because the attacker knew where he was going and the defender, blind in the gray, did not know where the threat would emerge. The Germans had chosen their conditions carefully. What they had not calculated was that the 30th Infantry Division and its supporting Sherman battalions had spent 2 weeks pre-registering artillery coordinates on every approach road, every likely axis of advance, every choke point in the terrain around Mortain. When the fog came, the Americans did not lose their vision. because their vision had already been converted into pre-computed firing solutions and map coordinates. The telephone network told tank commanders where German vehicles were moving. The artillery barrels were already aimed. The infantry tank link that had been improvised in a Pacific jungle and standardized in 6 months was operating in the dark exactly as it had operated in daylight. The fog the Germans picked as their opening became the exact conditions the American system had been built for. The counteroffensive collapsed in 3 days. It was the last major armored offensive Germany would attempt in the West. The second battle was Ericourt, Lorraine, September 1944. The open ground, the kind of rolling country where the Panthers' superior gun range was supposed to be decisive, where the Shermans' limitations should have been most exposed. The 4th Armored Division met the 111th and 113th Panzer Brigades in the fields east of Nancy. By every hardware comparison, the Germans held the cards. The 4th Armored finished the engagement with a kill ratio of approximately 3.6 to 1 in their favor, on open ground, against Panthers. The American after-action analysis was not triumphalist about it. The reports were methodical. They credited awareness, response speed, and communication between armor and infantry. The Sherman commanders knew the terrain. They had pre-planned firing corridors. When the Panthers appeared through the morning fog, the American response was measured in seconds. The Panthers were engaging targets they could barely see. The Shermans were engaging targets their infantry had already identified and reported. System integration. That was the Army's phrase in the reports. Not superior armor, not superior firepower. System integration. The same system assembled piece by piece in the bocage worked on open ground just as well, because the fundamentals hadn't changed. The tank that could see first and respond first still owned the first 30 seconds of every engagement, regardless of terrain. The German after-action reports from Normandy and Lorraine share a tone that becomes recognizable once you have read enough of them. The language is controlled, formally precise, professionally correct, but the frustration underneath is legible in the careful phrasing of conclusions. The reports describe an enemy combined arms system that did not respond to established anti-tank doctrine. They describe the unexpected coordination between American infantry and armor as a tactical problem for which standing German doctrine offered no effective counter. One divisional report from late 1944 noted that direct anti-tank action against American armored formations using available infantry weapons had been rendered operationally marginal. Written 8 months after the bocage had been described as perfect killing ground for exactly those weapons. One more thing. The history books leave it out, but it's part of why the numbers came out the way they did. A knocked-out Sherman could frequently be recovery towed to a field depot, repaired, recrewed, and returned to its unit within 48 hours. A Tiger I whose final drive failed, and they failed chronically, a known mechanical liability that German engineers had not solved by the end of the war, was, in the majority of cases, a permanent loss. The German logistics chain could not move complex armored vehicles to and from repair facilities at the rate they were breaking down. The Americans could. A Sherman burning on the side of a Norman road was often back in action before the Tiger that knocked it out had received its next fuel resupply. The war of attrition was always going to end one way, and the man in the hedge. By August 1944, German Panzerfaust teams operating in the bocage were filing reports that described the American Sherman column as functionally unambushable by infantry anti-tank means operating under standing doctrine. Not impossible to damage, tanks were still being lost, but that approach had stopped working at a rate that justified what it cost. The men who continued to try were not ignorant of the math. They understood what the numbers said: a 73% probability of death or capture in exchange for a 10% probability of success. Some were given no orders that left room for a different choice. Some made the calculation themselves and went into the hedge anyway, because the war had reached the stage where most of the remaining options had worse numbers. The man from the beginning of the story did not fail because of bad aim. He did not fail because his training was inadequate or his nerve broke. He picked the right hedge. He chose the right angle. He followed a doctrine that had worked in June, before something inside those tanks changed in ways that no one watching from a hedgerow could have seen. He failed, because the machine he was trying to kill had borrowed someone else's eyes before he could fire. It had turned its gun faster than he could run. It had driven through the wall he believed was solid. The hedge is still there. The Norman bocage is not a postcard landscape. Generations of farmers maintained it the way their great-grandparents did. And the banking is still 4 feet of packed earth, and the roots still 15 feet deep. Drive the road from St. Lo toward Mortain on an autumn morning, and the hedgerows look unchanged, because mostly, though they are, the war moved through them like a current through a wire. The current is gone. The wire is still there. Somewhere in that country, in a lane that looks identical to every other lane, is the section of bank where a man waited with a weapon that should have worked. The Sherman that drove past him is gone, scrapped and repurposed decades ago into something with no memory of Normandy. The army that built the Sherman is a memory of an industrial capacity and an institutional culture that may not exist again. The hedge is still there. That is what the hardware comparisons miss. They compare the machines as though the machines were the story. Tiger against Sherman. The 88 against the 75. Armor thickness against armor thickness. Gun caliber against gun caliber. As though the outcome could have been calculated from the specification sheets alone. The machines mattered. But the machine that won at Mortain and Ericourt, and in 10,000 unnamed lanes between St. Lo and the Rhine, was not the one with the better individual ratings. It was the one that could borrow someone else's eyes, drive through a wall, and turn its gun in 15 seconds after it found out you were there. The man in the hedge knew the geography. He knew the weapon. He knew the doctrine that had worked. He didn't know about the telephone,